Mathematical models make everything possible. To create them, specific training and resources are essential. At the universities of Vigo and Coruña, the ITMATI has its own research teams. First of all, it's essential to engage in conversations, perfectly understand the problems of the field, and make mathematical models of those rigorous models to reproduce these situations on the computer. These are complicated equations. Then this results in the development of software which is later given to the company. Or in scientific advice about modeling aspects or numerical methods, or even about the professional software firms are using. In A Coruña, there are 7 senior researchers and 6 PhD students working on applied mathematics. Their main interests of work are insurance, finance and acoustics, where mathematics plays a pivotal role. Applying mathematics and statistics to many of the problems companies are faced with obviously increases the knowledge of their problems, allows them to get solutions, and helps them to improve, to be more efficient and more competitive. This lowers costs when it comes to assessing risks or implementing prototypes. They also pay special attention to statistics and operations research, with a clear objective. Our field is completely cross-cutting. That is, all companies and the administration have a huge collection of data. Their objective is to get information about this data for decision-making, for an improvement in decision-making. So the techniques derived from statistics and operations research help us to get good information to allow us to come to correct decisions. For this reason, more and more companies are demanding this kind of service. Right now, they have several active fronts. We can mention that we're working on a problem about detecting particles in aviation fuels for an aeronautical company, which manufactures filters. Now we're starting to collaborate with a multinational firm on environmental problems. We have a relatively broad range of companies from different industries we usually collaborate with. Training is essential to form more and more teams which could offer this kind of service to companies. Well, it's a very cross-cutting field and is behind a great deal of current technology. So, in that sense, it's very important to train people in this moment of recession in disciplines related, for example, in the case of mathematics, to industrial mathematics. And in that respect, we also have a master's degree in industrial mathematics, which derives from a master's degree in mathematical engineering. It'll be available from next year on at the 3 Galician universities, together with 2 Madrid universities interested in our project. It's a bit like the recruiting ground to train professionals who could later join companies' R&D teams or technology centres, or even set up their own companies. At the University of Vigo, there are several projects in progress, some of which are very ambitious. We're working on an important project about the thermal analysis of the human foot in shoe conditions. That's to say, wrapped up in a shoe, which is interesting for the sports footwear industry, especially to take into account the type of materials in order to design this footwear, as well as their properties with regard to transpiration and, of course, comfort. It's essential for companies to be able to get results quickly, have the possibility of considering different situations, and especially reduce costs. Initially, the main idea behind it is to save money. Why? Because before getting involved in a process, getting to know the energy costs that this process is going to generate, etc., we can make an estimate by solving models on the computer. and get estimates of these costs and these expenses, right? And it's also about certainty, of course, because logically, when we're manufacturing parts, we want them to be faultless, and therefore we can previously carry out an analysis of the areas where this part is going to be subjected to more loads, what it has to bear. That is pure mechanics. In Lino Alvarez's team, they're really focused on the environment. Mathematics should play a very important role, which it's not playing at the moment, but it should, in the prevention and remediation of environmental problems. Monitoring sea currents, maximizing water and air quality, keeping the richest areas of the Ria valleys clean. Everything is possible with mathematical models. An electricity company builds a dam for a hydroelectrical power station, and this prevents the fish which usually travelled along this river from leaping over this dam. I mean, let's say that the fish gets here and it can't leap over the wall. Then, by law, they compulsorily have to build what is known as a fish ladder, which is basically a sort of canal with a series of little walls where the fish has to leap up through. Normally, these ladders are prefabricated and don't work well. That's to say, they don't take into account the water flow, the height they have to jump, or if in that river there are eels or salmons. Their size is completely different, so what we do is to specifically design for a particular dam the best shape for a fish ladder. We aren't really aware of what mathematics means in everyday life. And people think that we, mathematicians, have our head in the clouds, thinking about abstract equations. And that isn't what mathematics is all about. There's a lot of mathematics, and a part of it solves real problems.